Hello students, in our last video we have discussed some of the phenomena of light, that is interference of light and diffraction of light. Now today I am going to explain the next phenomena of light, that is polarization of light, by considering that light is a wave. We are discussing about the wave optics. So initially the Huygens has considered and he has explained the wave theory of light, and Huygens has explained that light is always traveling in the form of wave. But there are two types of wave, transverse wave and longitudinal wave. So the sound wave is traveling in the form of longitudinal wave. In the same way, initially the Huygens has also considered that yes, the light is traveling in the form of longitudinal wave when the light is behave as a ether. Okay, so he has explained that in ether, when the light ray is traveling the medium ether, then it is traveling in the form of longitudinal wave, and by considering that the light is traveling in the form of longitudinal wave, he has explained some of the properties of light like reflection, refraction, interference, diffraction. These all properties the Huygens has explained, or the scientists have explained, by considering that the light is traveling in the form of longitudinal wave. But when itself Huygens come to explain the phenomena of polarization of light, then his assumption is becoming wrong. Means, to explain the polarization of light, Huygens has to consider that no, light is actually not traveling in the form of longitudinal wave, it is traveling in the form of transverse wave. And this is assumed in year 1690 by the Huygens, when he is going to explain the phenomena of polarization of light. And after the 140 year of work, the scientist came Fresnel, and he has proved that yes, light is traveling in the form of transverse wave. So first of all, we will see experimentally how the transverse wave is traveling. That here you can see I have drawn the diagrams, two diagrams you can see. First diagram is the two cardboards are taken here, and in both the cardboards S1 and S2 two slits are cut. After that, both are kept mutually perpendicular to each other, and their slits are also perpendicular to each other. Now a rope is taken, and a person will suppose standing at the position A, and a person will stand at the position B, and when we will do up and down his hands, जब ये शेक करेगा रोप को, कोई भी पर्सन जो ए पोजीशन पर खड़ा है, तो ये इसमें एक वेव्स क्रिएट होंगी रोप्स में, एंड इट विल पास थ्रू दिस स्लिट S1, and after that the transverse wave, in the form of transverse wave, when it will enter in the S2, then both the slits are perpendicular to each other, so it will easily transfer, and the person B can also see the transverse wave coming from A to position B. But in the second diagram you can see that I have drawn that at the position A a person is there, but the slit of the second cardboard position is changed here. This is kept परपेंडिकुलर टू द फर्स्ट वन, मतलब जो फर्स्ट वाले का स्लिट था उसके परपेंडिकुलरली सेकंड वाले के स्लिट को यहाँ पे कार्डबोर्ड को पलट दिया गया. नाउ व्हेन द पर्सन ए विल shake the rope up and down, so the transverse waves will originate, but when the transverse waves will enter in the second cardboard, means secondary source, then its amplitude will become very small or becomes negligible, and the transverse waves are not observed here as it was initially. It means what? इसका मतलब क्या है कि यस, ट्रांसवर्स वेव्स एक जगह से दूसरे जगह ट्रांसफ़र हो रही थी जब दोनों म्यूचुअली परपेंडिकुलर थे स्लिट्स, और जैसे ही हमने इनके डायरेक्शंस को चेंज किया, जब ये पैरेलल थे ट्रांसफ़र हो रहा था, जब हमने इनको परपेंडिकुलर किया, चेंज किया, ट्रांसवर्स वेव क्रॉस नहीं हुआ दूसरे स्लिट से. इट मीन्स अगर ये लॉन्गिट्यूडनल वेव होती तो ये एक जगह से दूसरे जगह क्रॉस हो गई होती, बट सिंस इट वॉज अ ट्रांसवर्स वेव, सो इट कैनॉट क्रॉस. सो on this basis the polarization of light is explained. So in the same way we will observe the experimental demonstration for the light. यहाँ तो हमने आपको एक एग्जांपल दिया कि कैसे अगर हम म्यूचुअली परपेंडिकुलर रख दें तो ट्रांसवर्स वेव्स रुक जाएंगी एक जगह से दूसरी जगह आने के लिए, जबकि अगर परपेंडिकुलर हो तो क्रॉस हो जाएंगी। ये मतलब नेचर है ट्रांसवर्स वेव्स का, ओके। जबकि अगर ये लॉन्गिट्यूडनल वेव्स होती तो ये चाहे हम किसी भी पोजीशन पे इन कार्डबोर्ड्स को रखते परपेंडिकुलर और पैरेलल, इट विल पास with the same intensity. Now coming to this second diagram, you can see here I have drawn a diagram. So a bulb is glowing in both the diagrams. This is a glowing bulb, okay. And in the first diagram, first of all you observe there are the two tourmaline crystals I have taken. Tourmaline crystal, the quality of the tourmaline crystal is that when a ray of light will pass, so this is the axis, it is cut in such a way that दिस इज़ द एक्सेस ऑफ द टर्मेलिन क्रिस्टल। इसके एक्सेस को बचाते हुए टर्मेलिन क्रिस्टल को कट किया गया है। टर्मेलिन क्रिस्टल इज टाइप ऑफ क्रिस्टल, इसका लोग रिंग्स वगैरह में पहनने में इसका यूज़ करते हैं इस क्रिस्टल का। सो एंड द क्वालिटी ऑफ टर्मेलिन क्रिस्टल इज दैट वेन एवर द ऑर्डिनरी लाइट विल पास थ्रू इट, then it will stop all the lights and it will only pass the light ray which will पैरेलल टू इट्स एक्सिस। ये सिर्फ उसी लाइट रे को पास करता है जो इसके एक्सिस के पैरेलल होती है। तो यहाँ पे हमने इस टूरमेलिन क्रिस्टल का एक्सिस ड्रॉ किया है, यू कैन सी, एंड दिस इज द ऑर्डिनरी वे ऑफ लाइट स्टार्ट्स, एंड ऑर्डिनरी वे ऑफ लाइट, द क्वालिटी ऑफ ऑर्डिनरी लाइट्स रे इज व्हाट, इट इज glowing in all the possible directions. After that, when it will enter in the first tourmaline crystal, then all the light rays are illuminated or absorbed by the tourmaline crystal, and only the light ray which was parallel to the axis of tourmaline crystal that passed from the first crystal. और ये फर्स्ट क्रिस्टल से पास हो गई। आप देख रहे हैं सिर्फ वो लाइंस पास हुई हैं, वही रेज पास हुई हैं जो इस एक्सिस के पैरेलल हैं, और इन लाइट रेज को हम बोलते हैं पोलराइज्ड लाइट। दीज आर द नोन एज पोलराइज्ड लाइट। एंड सपोज इफ आई विल इंट्रोड्यूस, सो व्हेन यू विल इंट्रोड्यूस ओनली वन क्रिस्टल between the eyes and the source, then you will see able to see the polarized light. Suppose if I will introduce one more crystal, that is crystal second tourmaline crystal. Now after putting this, consider this P1 and this is crystal P2. When you will introduce the second crystal P2 perpendicular to the first one, parallel to the first one, जब आप इसके पैरेलल एक और क्रिस्टल को रख देंगे तो आप देखेंगे कि इससे भी वो सारी लाइट रेज पास हो जाएंगी, क्योंकि इसका भी तो एक्सिस इन लाइट्स के पैरेलल ही है। तो पैरेलल लाइट्स को ये इल्यूमिनेट नहीं करता है टूरमेलिन, अदर लाइट्स को। देन इट विल ऑल्सो पास, एंड हेयर विथ आइज यू विल ऑल्सो सी द पोलराइज्ड लाइट, एंड हेयर द इंटेंसिटी ऑफ लाइट इज मैक्सिमम। आप उतनी ही मैक्सिमम इंटेंसिटी की लाइट वहाँ पे गेट करेंगे जब लाइट रे इस सोर्स से होकर दोनों टूरमेलिन क्रिस्टल से होते हुए पास करेगी। नाउ coming to the second diagram, this is the source of light again I have drawn, and the first tourmaline crystal. So ordinary ray of light is when passing through the first crystal P1, then the polarized light will be seen, on other lights will be illuminated. After that we will change the position of the second tourmaline crystal, that is P2. इसको अब हमने पलट के चेंज किया इसका पोजीशन, और इसको हमने परपेंडिकुलर, इसके एक्सिस को हमने फर्स्ट वाले एक्सिस के परपेंडिकुलर कर दिया। अगर पहले वाले का एक्सिस ऐसे था तो दूसरे वाले का पलट के हमने ऐसे कर दिया परपेंडिकुलर। तो यहाँ से तो हमने पोलराइज लाइट मिली फर्स्ट वाले के बाद, वी हैव सीन द पोलराइज लाइट। बट सपोज नाउ इफ दिस रेज विल पास थ्रू द सेकेंड क्रिस्टल, सो द क्वालिटी ऑफ टूरमेलिन क्रिस्टल ओनली इट विल पास द light rays which will parallel to its axis. Now its axis become like this and light rays are like this, so it is not parallel, these become perpendicular, so it will illuminate these light rays, and here you will see the light, the intensity of light will very minimum or negligible or zero. You will not able to see any polarized light or any light when you will keep two tourmaline crystals perpendicular to each other. So like this the phenomena of polarization is explained. It means you can say that in the polarization of light, you can say that when the light ray, means light rays are traveling in the form of electromagnetic wave like this, you have seen, I think this is the direction of propagation of light, and the light rays are traveling in the form of electromagnetic wave. You all are familiar about this. Once again I am drawing. this is the suppose electrical field and this is the magnetic field of lines. And electric field of line and magnetic field of line both are always perpendicular to each other. Suppose its direction is this and this direction is this, so perpendicular, and the direction of propagation of this means the electric field vector and the magnetic field vector and the propagation of light in the electromagnetic ray all are mutually perpendicular to each other, and actually the light ray are always traveling in the form of electromagnetic wave. So if it is traveling in the form of electromagnetic wave, so both mutually perpendicular rays are going. So once the electric field is illuminated and then the magnetic field is illuminated, and finally the no any rays is seen after the passing, means both mutually perpendicular nature of the electromagnetic light rays will be illuminated by these two mutually perpendicular tourmaline crystal, and no light rays will seen here. So this is the phenomena, and the such a wave which we will see after passing the light from a single tourmaline crystal, this light rays are known as plane polarized light or linearly polarized light. Okay, and this phenomena by which we can able to see the plane polarized or linear polarized light, that phenomena is known as polarization of light. Okay, so this is such a wave which are plane polarized or the linearly polarized are known as phenomena is known as polarization of light. And one more thing I want to explain, in this experiment the first tourmaline crystal P1 is known as polarizer. Why it is polarizer? Because after passing through the first tourmaline crystal, the light rays become linearly polarized. Polarized light we can see after the first one. So this is known as what? Polarizer, this first crystal. And after that the second crystal by which we are observing the nature of the light, like if it is parallel to this, then we will see the polarized light. If it will become perpendicular, then the intensity of light will become minimum or maximum. तो ये जिससे change हो रहा है इसकी nature, so that second crystal is known as analyzer. So this is polarizer, first one is polarizer and second one is analyzer. So that's it in today's video. Today we have discussed the light rays, transformation of light rays, and plane polarized and linear polarized light, and the experimental observation of the polarization of light. The further topics of the polarization of light we will discuss in our next video. So thank you.